reviewer.
Mention it before and after the test.
Okay, overcurrent protection devices. We're going to talk, guys, about Article basically 240. Article 240 says if you have a piece of equipment breaks or a circuit breaker, you need to protect the piece of equipment, the circuit breaker, from an overcurrent condition. The three most common ways of protecting from overcurrent condition, guys, it's fuses. The two ways of protecting is fuses and circuit breakers. Ground fault is later on, we'll get it. So every conductor, every panel, every piece of equipment, you need to protect it from overcurrent condition. I want to emphasize, guys, the overcurrent condition. Overcurrent condition has three key components. One is overload, and the other component is short circuit, and the third component is ground fault. So every single conductor, every single equipment, every single machine, every single panel must be protected from overcurrent condition. Overcurrent conditions are three different types. One of them is the overload. And overload, we talked, guys, about overload. Overload, if you have a conductor that's rated for 15 amps, and Chanel single-handedly you went and you loaded that 15 amp conductor with a 25 amp conductor. That's an overload condition. You double the amount of current in it. Maybe 50% more, double, maybe triple. That's an overload condition. Short circuit, you have a three-phase circuit and you grab phase A, phase B, and phase C, and you bolted them together, the three phases together. That's a short circuit. That's a short circuit. So the impedance will be extremely small. The amount of current will be extremely high. So if you guys want to, in terms of multiplier, if this is my current equal I, normal current. This is normal. If I have a normal current, guys, of I, then the overload would be probably from 1 to 2 times I. That's an overload condition, from 1 to 2 times I. Does that make sense? If your current is 10, an overload condition would be between 10 and 20. Does that make sense? So multiplier of 10 means you double the current. That's an overload condition.
Sorry, my phone just went out.
A short circuit condition, let's just go to the ground fault. Ground fault condition, guys, probably can go from 4 all the way to, I would say, all the way to 8 times the current. So if you have a 10 amp, if you guys have a 10 amp load and you load it, and 10 times 8 is what? 80. And you have a ground fault on it, most likely the ground fault will be 80, close to 80. Does that make sense? If you have a 10 amp load and you short circuit that conductor, most likely that conductor will be carrying 80 amp short circuit, a ground fault. The other one, guys, probably from 10 to 20, give or take, times I. If you have a 10 amp conductor and you have a short circuit, line to line, 3-phase, line to line, or 2-phase, most likely your conductor will be, if it's 10 amp, most conductors will be between 100 and 200 amps short circuit in it. Again, these are just numbers, just to give you an idea. I can't emphasize, guys, the ground fault, the overload is a small amount of current, extra current. The ground fault is the next step of extra current, and the highest amount of current that you can get is the short circuit. Any questions about overload?
Arc fault.
Arc fault is a special type of a ground fault or a short circuit. Special type of ground fault, high impedance. They call it high impedance.
Yeah.
So that's Article 240. Article 240. We're going to talk, guys, about the circuit conditions. Circuit conditions, 5 possible ways of circuit conditions, and operation of circuit breakers and fuses. A fuse is one-shot deal. You hit it, it works. A circuit breaker, you can reset the circuit breaker. Single pole, 2-pole circuit breakers are extremely important. We'll talk a little bit about this one. Interrupting rating of circuit breaker, fuse or circuit breaker, and the available short circuit. I have a little formula. We're going to calculate the available short circuit. Available short circuit of the equipment. I want you guys to put a keynote here under understanding a series rated and fully rated equipment and selective coordination. This is will ease us, Spencer, into next quarter. That's we're going commercial now. We're going to see if you have a panel. How can I what's the difference between buying a panel, the same panel, if it's series rated or fully rated? You're going to see the prices double between fully rated and series rated. What is series rated? What's fully rated? And how do you conduct overcurrent protection coordination? It will touch on it, guys, and I promise you next quarter we're going to have a software, we're going to have a lot of stuff. We're going to help us do overcurrent protection coordination. So that's going to be eased really into next quarter. Just a reminder, if you forgot, that online fuses are one-time deal. It works. You trip circuit breaker, you can reset them. That's the advantage of circuit breaker over fuses, guys. And if you get into whole argument, which should I use, guys? Chad, should I use a 100 amp fuse panel, or really it's not 100 amp? Say if you have a 2000 amp, you have a 2000 amp switch gear. Should I use a 2000 amp fused fused switches, or should I use a circuit breaker? I want you guys to hold this question until we bring Square D. Square D will come over here. Jerry will be here from Square D, and he will talk about the advantage of fused over disconnect. Just in one word, I want to summarize it to you. Engineering-wise, a lot of engineers go for circuit breakers. Circuit breakers are intelligent devices. You can talk to them, pull information from them. Fuses are dumb devices. One-time deal, they cut it, and it's over. You replace it. That's a disadvantage of fuses. Is they do one work, one time. They don't live to fight another battle, and they're not intelligent where you can talk to them at a level of 2,000 amps and higher. But the good thing about the fuses, though, the fuses, Spencer, is they size them specifically for the load. You can find a fuse over here. The fuse manufacturers, they can tell you, I guarantee you, if you have a short circuit, this piece of equipment will not burn after it clears the short circuit. The circuit breaker don't have this type of guarantee. The circuit breaker guarantee you that if you have a short circuit, we will interrupt it. After we interrupt, what happened to the cable? Is the cable damaged? How much damage happened to the cable and the circuit breaker, the cable here, and a transformer? The circuit breaker don't guarantee that. That's kind of the disadvantage of circuit breakers. Fuses are, there's so many types of them, guys, that you can size a fuse that specifically, if you have a short circuit, I guarantee you that this conductor, nothing will happen to this conductor. It's not going to be even damaged. At the circuit breaker, you have a short circuit drive, it will interrupt it, but the conductors at the end, you might have to go change the conductors. Just a small, not all of them, at the end, the terminal right here, they might burn. So that's kind of advantage of fuses. Advantage of fuses, guys, fuses also current limiting. They have a lot of current limiting fuses. If you have a short circuit right at this terminal, right here, if the short circuit is 20,000 amp, and this equipment is rated only for 10, what are you going to do? If the short circuit calculated right at this terminal 20,000, and I bought a transformer that's rated for 10, two things could happen. If you hook up this transformer and you have a short circuit right in here, this transformer will blow up, completely burn. It's not rated for 20,000, it's only 10. Or there are they call them current limiting fuses, guys. You buy a filter, it's like a filter. You put a current limiting fuse right in here, it takes the 20,000 amp and it filter it, block it and reduce it down to, of course you have to size it properly, it reduces it down into 10. So now you can have a 10,000 amp transformer hooked up to a system that the available short circuit current and it is 1. Why? Because I have these filters, which is fuses. They call them current limiting fuses. That's a major advantage of fuses over circuit breakers. Circuit breakers don't have them. They don't have them. Yeah, there's some exceptions, but for the most part, they don't have them. A couple of things, guys. Obviously, because the circuit breakers can't trip, if the circuit breaker trip, the first thing you do is Mr. Pugh. The first thing, if you have a short circuit in your and it trips, you're not supposed to go reset the circuit breaker before you go check why the circuit breaker tripped. Why? Because if it tripped and you go close it and you have a short circuit, what happens? It's going to trip again. It's not a big deal if it's 15 amp circuit. If it's a 2000 amp circuit breaker and you go close it on a short circuit, you're going to see that a huge amount of energy hitting. It might hurt. It might damage your hand as you close it. That 2000 amp and you close it and it shuts immediately because it's a short circuit. It could blow right in your hand or hit you right in the hand as you close it in a short circuit. Big deal, guys. So In a 15, 20 amp, 30, 40, 50 amp circuit, not a big deal. Nobody get hurt. Um, we mentioned this one, guys. Both fuses and circuit breaker are listed for overload, short circuit, and ground fault. And all these are fancy names for different levels of current, different levels of current. The overload is the lowest level of current. The ground fault is the second, and the third highest, or the highest is the short circuit. Different levels, the same current, different levels. And the same thing, wiring and equipment, guys. Wiring and equipment. I have my AC system here, and I have my overcome protection device. And remember, I don't know how many of you guys remember where they have fuses. If you remember when we were talking about AC systems, they said the manufacturers want you a certain AC system. They want you to put a fuse disconnect right next to the equipment. You guys remember that? These scenarios. First of all, you have a circuit breaker here. This circuit breaker is to protect the cable. And then the manufacturers say, Brad, who the heck are you to go size an overcome protection device to protect my equipment? I have my own engineers in-house that can design a specifically designed fuse that can protect my equipment, and I care less about your overcome protection device ahead of me. A lot of manufacturers, guys, protect their equipment. So what do? They have a tiny little beautiful fuse, properly sized, designed, type-wise and size-wise, and they stick it right ahead of the equipment, and this fuse will protect the equipment. Is special protection for the equipment. Most of equipment, guys, high-profile equipment, they're going to have their own protection. So what does this circuit breaker do then? This circuit breaker really is doing, in reality, is just protecting my cable from here to here. You have any short circuit right in here, or overload or ground fault, my circuit breaker is responsible for this section. This piece of equipment will be fully protected by the manufacturer provided fuse disconnect. And why do we protect from overload, guys? Who cares? Why can't I, if this cable is supposed to carry 100 amp cable, why can't I make it carry 1,000 amp? If you don't care about smoke coming out of the installation and fire in your building, not a big deal. You know, if you put 1,000 amp into 100 amp cable, what's going to happen? It will carry it momentarily, guys. It will carry it for a couple of seconds, but eventually it starts heating up because high current creates heat, the resistance of the heat until smoke starts coming out of the installation, and hopefully by that time it shorts and the circuit breaker will wake up.
What was that order?
Oh, the order for in terms of lowest current to highest current, the order is this will be the lowest, number one. The lowest, and the second lowest is this 2, and 3 is the highest. Where's short circuit? Short circuit right here. Short circuit 3. So if I am to draw, guys, the short circuit, this will be this amount here will be the overload. If you go up, this will be the ground fault, and if you go all the way up, this will be the short circuit. So this one is short circuit. This one here is ground fault, and this piece here is overload. See how the overload current, high current. They're all current. The reason why I say Jim all current, because if for some of you guys some of you will be at one time working with over voltage, under voltage protection, under frequency protection. There's a lot of protection, guys, other than over current. Overcurrent is only one type of protection that we do in the power industry. There's under over voltage, under over frequency, directional current, tons of other protection. The most common protection is the overcurrent protection. Uses a fuse or circuit breaker. Any question, my friends? What if I say everybody's going to get an extra credit here? Would you say no? No, it's not. I bet you the Gulf of Mexico is not going to wash the hurt that happened to you. Basic fuse type. Fuses, guys, for the most part for you only need to know about one type, Spencer, the cartridge fuse. The only type that you want to worry about is the cartridge fuse. The other plug-in fuse, these tiny little ones that you screw in, plug-in fuse, they're rated for 120 and they're limited to 30 amps. And they use tiny little ones, guys. These are the old panels that used to use them, screw-in fuses, mostly to protect loads, small loads. Tiny little loads, for example, commonly used, guys, if you have a garage door opener and you need to protect the motor of the garage door opener, specific protection for the motor. So you have this box, a tiny little plug-in fuse, and you size the fuse small enough to protect the garage door opener. So for the most part, guys, unless you're an electrician, you really are not going to be doing a lot with the plug-in fuses. Cartridge fuses are your babies. These guys, they can get them from close to 300 volt or 600 volt, and you can go from 1 amp, well, I don't know from 1 amp, but I'm going to say from 0 amp all the way to 6,000 amps. Now, Spencer, here's my 4,000 amp switch gear. When you size a 4,000 amp switch gear, they're going to ask you, okay, Spencer, what type of switch gear do you want it? Do you want a fused switch, or do you want a circuit breaker? And the difference in price, guys, the circuit breakers are double. Almost double at the higher level. So that's where you're going to ask. They're going to ask you. You have a 4,000 amp, 400 amp panel. When you in a commercial building, the question would be: should I make a fuse disconnect, or should I make a circuit breaker? What's the best if you ask an engineer? Is of course circuit breakers, because again, intelligent devices reused. Intelligent devices reused. Cheap, which one is the most economical? A fuse disconnect are cheaper. A fuse disconnect, guys, also bulkier. So if you have a 600 amp panel, circuit breakers, it would be that size. If the same panel, 600 amp fuse and a disconnect, it has a disconnect with it and a fuse, it will probably be twice as big, large. Why? Because you have to accommodate for the disconnect. You have to have a disconnect ahead of the fuse and the big fuse in it. Versus circuit breaker, the circuit breaker itself is a disconnect and a fuse on the overconduction device. So that's kind of the disadvantage of the cartridge fuses. But these, for the most part, guys, two types. The plug-in, they're different. All these W and T and TL, all these guys, and I'm going to leave this one to. Don't ask me too much about the differences. First of all, we don't care too much about the single non-time delay fuse. There's this one, the W is called non-time delay fuse, time delay fuse, and loaded link time delay fuse. Non-time delay fuse, guys, is just it sees a short circuit and bam, it opens. It melts. Time delay fuse, you use it in motors. It sees a high amount of current, then it sits for 10 seconds, and then it opens. Why? It allows the air rush in the motor. The air rush in the motor, it looks like 10 times, 6 to 10 times higher than the full load current of the motor. It looks like a short circuit. So if you put a non-time delay fuse, guys, on a motor, you have two options. Either you oversize it, which is if you go to the 430.52, you have to multiply by 2.5. But if it's a time delay fuse, guys, dual element time delay fuse, you can actually multiply by 1.75. No problem. Why? Because I see 10 times more current coming out of these cables. A time delay fuse will sit and basically count to 10, almost 10 seconds before it melts. A non-time delay fuse, right on the spot, it opens. So you put it in a motor, unless you size it properly, every time you start the motor, what's going to happen? Melts. So these ones, just FYI, these are commonly used for feeders. These are commonly used, and you can use anything at anything. Commonly used for motors. Commonly used for motors. Loaded link time delay fuse, a special type. This is dual element, give you overload and protection. Loaded link time delay fuse is another time delay fuse that you can also use in motor. Dual element. The idea with the dual element, guys, is again overload. It can also protect you from overload and short circuit. So these are the same characteristics, guys, with also the same characteristics here. You can buy them, the same characteristics for a cartridge fuse or a plug-in fuse. Same characteristics. A couple of things here, cartridge fuses, the voltages, 300 to 250. I want to add 10 here. You can buy the cartridge fuses. These are big boys, cartridge fuses, all the way up to 6,000 amps. Different types are, and you guys will wait until different CC and G and T. These are all different types. Is it current limiting fuse? Is it time delay fuse? Is it dual element? What characteristics do I want this fuse to do? for the most part, guys, for the most part, you're either dealing, most fuses, at least power industry, engineering-wise, you're either dealing with non-coordinate fuse on feeders, or dual element coordinate fuse in circuit breakers, or current limiting fuse. And the only time you buy Brooks, a current limiting fuse, is if your equipment is not rated to handle the available short circuit. It's the only time you have a current limiting fuse. Current limiting fuse.
Do you know the difference on the fuses, like the S and the PO in there?
Well, the little S that they put it, they don't want you to put a 20 amp in a slot of a 15 amp and overfuse the overfusing.
Besides the base.
Yeah, they stick it into the base of the fuse, so you can't overfusing, guys. If you have a fuse in the past, the plug-in fuses, instead, like if the socket can fit 15 and 20 amp. So if I go take the 15 amp fuse and put 20 amp fuse, what happens to the conductor? The conductor is number 14. You burn the conductor. To prevent that, they have this little S deal that you plug it in to prevent you from doing that. But that's not really at the design level, probably at the electrician level, or it is at the electrician level. Okay. So overload occurs. We talked about the overload, guys. Overload occurs when you excessive of current. How do you make if this is a 20 amp circuit? How do you make the conductor carry 25 amp circuit? Right here, it's a 20 amp circuit here. How can you make it carry a 25? You keep adding lights to it, right? Keep adding lights to it. A lot of lights, and turn them all on at the same time. Add the amps of them, they will exceed the 20 amps. That's an overload condition. Short circuit, we know what short circuit is. Grab phase A and phase B and slam them together. Ground fault, grab the conduit, grab the conductor right in here, one of these conductors, take it and put it against that conduit. That will be your ground fault. So these are a few things. Okay, the way the circuit breakers, guys, work is if you have a low impedance path, dramatic surge in the current, the circuit breakers have, and I will promise you, we'll talk about electronic circuit breakers versus thermomagnetic circuit breakers. Thermomagnetic circuit breakers, the magnetic part for the short circuit. Magnetic part for the short circuit sees a huge amount of current. It creates a magnetic field that physically, mechanically open contacts in a circuit breaker. If it's an electronic, there's a sensor. Spencer, you have that sensor around the conductor. It senses the current. If the current is supposed to be 100 amp here, and all of a sudden it reached 20,000 amp, that sensor takes the signal directly into the brain of the circuit breaker and initiate a signal that goes to the contacts, the fold over contact, to energize it to open immediately or with delay. So it's really sensing the current and making a decision. Okay. Energize the circuit. So that's the whole idea, guys, of a circuit breaker, to protect you from over current conditions, overload, short circuit, or ground. A couple of things about single pole circuit breakers. If you have a single pole circuit breaker, you have to use it in 120 since we're residential. If you have a two pole circuit breaker, it's meant two pole circuit breaker is going to be rated for 240. But you also, as you know, if we have a multi-wire circuit, Muhammad, my friend, do you remember if we have a multi-wire circuit, what do we need to do with the circuit breaker that feed the multi-wire circuit? We have to, anybody remember? Tie them together. We have to tie them together. So if I have a multi-wire circuit, here's one, here's two, tied together, 20 amp. This was my garbage disposal. This is my dishwasher, garbage disposal, dishwasher. And I brought one neutral and grabbed the neutral and fit it, right? Isn't that what we did in the kitchen? A multi-wire branch circuit feeding the garbage disposal and the dishwasher, shared neutral. In a situation like this, guys, these will be single pole circuit breakers tied together. This is what we call, remember the split receptacle, how we split this receptacle for dishwasher and garbage disposal? We taught it. The handle, if you are to use two circuit breakers, guys, single pole circuit breakers, with the handle between them, Spencer, have to be listed, approved by the manufacturer. In the past, they used to, there's a hole here, they have a hole here. They used to list them, guys, by putting a wire, just a tiny little wire, copper wire, get the insulation out and put the copper wire and bend the copper wire from both sides. Now these are tied together, and they use them on a multi-wire branch circuit or a two-pole. That's not approved method. The approved method in the factory, we have to have them coupled with an approved method. So that's what.
The little, I device from the other day, the little plug things.
So it has to be an approved method. But the wire part that we used to do, put them and tie them together, this is not an approved method. The reason, guys, behind this, my understanding, I could be completely wrong, is they want them to trip, when they trip, they want to trip both of them at the same time. They want them to trip both of them at the same time when you open them. And look at that, the handle tie, don't listen to my friend DJ here, has to be tested and listed. Tested and listed. Specific manufacturer circuit breaker. So it has to almost come with it. Can I use a two-pole circuit breaker, guys? Two single-pole circuit breakers on an air conditioning. I can. Two-pole tied together on an air conditioning. When we go to the commercial, this is 122.40. When you go 208, 120, guys, and 480, 277, if you have an air conditioning that running at 480, you cannot use two-pole, 277 each tied together. So I want you to remember that two-pole tied together for a 240 only work on residential. You go to the commercial industrial, then if you have a load that's two-pole, you need a two-pole circuit breaker, just one big fat circuit breaker with one mechanism, with one handle. If you have a three-pole circuit breaker, you put the three-pole circuit breaker on a three-phase load. A three-phase load, you have a one circuit breaker, three-pole, with one handle that goes into the three-phase circuit breaker. So keep this in mind. The rating indicates the maximum current. Circuit breakers and fuses, guys. The code says, and you don't have to remember this one, this is in the code. If your circuit breaker is rated for more than, if your fuse, let's go to 110.9. I believe if your fuse is rated for more than 10,000, you have to put a label on it. If your fuse is rated more than 10,000 amps, you have to label it. 25,000 amps, 22,000 amps. If it's more than 10,000. If it's not labeled, then it's listed for 10,000. For circuit breakers, guys, I believe, if I remember right, if it's rated for more than 5, if it's 5K or less, if it's more than 5K, then you have to list it. For example, most of the residential stuff, if you read through these, it's going to tell you most of them are 10K. What does a 10K is? Means if I short anywhere here, this circuit breaker can handle up to 10,000 amps. What happens if you put 20,000 amps in it? Blow up. Very, very simple. Blow up. So that's the maximum current the circuit breaker can do. Safely, I emphasize the word safely. It will de-energize, but not before it blows up. These are the stages of a circuit, guys. Open circuit. If you have a circuit, if you have a circuit, I don't have the normal circuit. If you have a circuit, one thing could happen to your circuit. Ben, that's what happened to your circuit in your house. You have an open circuit condition. The neutral is open. You know, open circuit. What happens if you guys have an open circuit condition? If you have an open circuit, on the hot, nothing will work. If you have an open circuit on the neutral side, also nothing will work. If you have an open circuit in a multi-wire branch circuit and you lost the common neutral, now you burned equipment in a multi-wire branch circuit. So that's an open circuit condition. Basically, somebody went and cut the wire, or obviously nobody's stupid enough to do that. But what happened, guys, is and the wire nuts got loose. It could happen. That happens all the time because of heat. You heat it, expand and contract. It got loose enough that the neutral conductor are disconnected now. That's an open circuit. That's an open circuit. I want you guys to remember, if it was an open circuit, this is a 240. This one is a 240. So the amount of current that goes in an open circuit is what? 0. The amount of amp that moves in an open circuit is 0. There's nothing moving in an open circuit. So that's open circuit. The second one is a ground fault. What is a ground fault? The ground fault, guys, is unintentional connection between a hot conductor and a grounded object. The grounded object could be the neutral. The grounded object could be the frame of this panel. The grounded object could be the grounding conductor. The grounding conductor right in here. Anything grounded. Anything grounded. That's a case where we call it ground fault. Ground fault. Bad news. Bad news. Overload. Here's a good example of overload, guys. You have this circuit is rated for 24 ohm load, and you single-handedly went and added 2 loads on it. So if you can see, if you do the math on that one, this circuit is carrying now 19, almost 20 amps, versus it was supposed to carry 10 amps. You added the loads, it's carrying 20 amps now. And the fuse is what? The fuse is a 15 amps. So what's going to happen? In a case like this, Brad, you'll be surprised. You can run like this for almost an hour. You will be run for this on a fuse or circuit breaker almost an hour until it heats the fuse hard enough to open. And the conductors can handle that overload. The conductors, number 14 conductor here, you guys remember number 14? Number 14 is rated for 20 amps. We don't load it 20 amps, but it's rated for 20 amps. So the conductors, the fuses will work within probably half an hour to an hour, it will open. If you have a situation, guys, where the circuit breaker trips and you know, trips often, but you go reset it and goes for another 3-4 hours and trips, that's an overload condition. That's a common overload condition. Meaning it takes it heats up, and until it heats up, it trips. Okay, a short circuit. Look what happened with a short circuit. A short circuit, guys, this is extremely important. A short circuit, you went and you bypassed the load. You basically grab the 2 hots and you tie them together. Now, Spencer, the impedance, what happened to the 24 ohm? What happened to the 24 ohm? 24 ohm is gone now. 24 ohm is gone. So then, if you find the current, I will emphasize this one. If you guys please look at this, because this is really, the question always comes is, why do I have a huge amount of current in a short circuit? Why do I have a huge amount of current in a short circuit? I want you guys to see the impedance, because the impedance goes so low. The impedance, look at that. I have the impedance of the conductors and the source. The only impedance in the system in a short circuit condition is the impedance of the conductors and the load. There's some impedance in the source here. That's it. So if you put the impedance or the resistance of this, add them up. These are in series, right? In series of conductors. Here's conductor in, conductor out, the 2 and 1 for the source. Add them up, divide the voltage by them, and that will tell you how much current. I can't read it here. That will tell you 80,000 amps. This is an 80 amp. That's a short circuit. Why do we have this amount of current? Because now that 24 ohm impedance out the window. I shunted. I went around it. So I think this is great for people who understand why does a short circuit create high current. Piece of cake. Because from Ohm's law, guys, very important. I equal E over R. Okay? Now what happens if R is almost 0? You agree with me that I in this case is going to shoot up to the sky. So the lower the I, the higher the current. The lower the I. Now in this case R was 24, but we dropped the 24 and we kept the 24 is bypassed, guys. The only impedance left is the impedance of the conductor and the impedance inside the coil, which is very, very, very tiny impedance, thanks God. Why? Because we need the conductor impedance to be very low, guys. But otherwise, the voltage drop will be high. So I always bring this one later on, guys. Next quarter, I want to tell you the advantage and disadvantage of having longer runs. And I will, if you have the advantage of having the load right next to the panel, what's the advantage having the load right next to the panel? Voltage drop is 0, nothing. What's the disadvantage? The high short circuit. The short circuit is extremely high. Why? Because look at the conductor impedance. If the conductors are too long, that impedance becomes high. Then it lowers the short circuit. If you're right next to the panel, the short circuit, right, if I put an equipment right next to the panel, the short circuit is going to be very high. So there's advantage and disadvantage of having the loads right close to the equipment, to the panel that feeds them. Yes, sir.
What would you, like, in the older buildings, with older wiring and stuff, do you think that the fuses are better breakers in the room?
For the nub and tube? For nub and tube? Not with the tampering with it. Ask people how many
Your black ones?
You know, pennies they put underneath them and they're oversized. I think the assumption right now is move it to circuit breakers because of tampering with them,
Even with that?
with everything. Because people, if trips, guys, they don't have the right size breaker. What do? They put that penny in behind it and lock it. Now you can burn the house because of that. Okay, short circuit calculation. Short circuit calculation. I promise you, my dear friends. I promise you, my dear friends, that we will be talking about short circuit calculation for a lot of times. I want to emphasize that hundreds, sometimes in a higher system, the short circuit will be hundreds of times more. I'm going to go just go over one tiny little tiny little thing to show you the short circuit calculation, guys. Let me just grab, very simple at this time anyway. If I go bring a short circuit calculation, yeah, here's a short circuit calculation, guys. I have, since we're residential, let's just stay with the residential. I have transformer. I don't care about the primary here, 7200 volt. The secondary is 240/120 volt. Here's the neutral, and here's the hots. Hot 1, hot 2, the neutral. I want to find, and this transformer, guys, is 75 kVA. The impedance of this transformer is 3%. I have a transformer coming to my house, 75 kVA transformer, and feeding, and the impedance, the impedance of the transformer 3. I need to calculate the short circuit. Very simple, extremely simple. The step, everybody's with us. I have a 72 volt, a 7200 in the primary, the secondary 240/120, typical residential. I'm not going to do 3-phase because we'll do it next quarter. And I need to find the short circuit of this system. Step number 1, my friends, is find the full load. Full load. If you have a transformer, can you find the full load current of a transformer? I hope so. You take the 75K and you divide it by what's the voltage and which voltage. We're looking at, guys, we're looking at the short circuit right in here. If I do a short circuit right on this side, if I do a short circuit right on the secondary of the transformer, how much current this transformer can pump into the short circuit? Pump. See, we're right at the second, not the primary, the secondary. So divide this by which voltage and why? 240 because it's line to line. So you divide it by 240. What will be my calculator for an extra credit, which you guys badly need it now?
313.
313 amp. Okay? So that's my full load current. The second step, guys, which is very easy to find, I short circuit line to line. I short circuit line to line equal I full load divided by the impedance, which is Z. It's called Z, the impedance. Piece of cake. So grab that 313 divided by point. This is impedance, 0.03. Spencer?
A lot. 10,400.
10.4K. Is that good enough? 10.4? 10.4 kilo amp. 10.4. So the available short circuit is 10.4 kilo amp. What does that mean to you? What that means to you? Now, Spencer, I need you to size me a circuit breaker here.
In the book, Chad,
Yeah.
it says kVA times 1,000.
Yeah, because, you know why? Because kVA times, we times it by 1,000 here, didn't we? kVA right here.
You're just converting it from a K to a.
Yeah, right away.
You're just making the.
You
Yeah.
can without writing it down.
I didn't write the K. You mean here multiplied by 1,000? It's already, guys, in the K.
It's saying kVA times 1,000.
kVA times 1,000, then you divide it by the voltage and you divide it by the impedance. Okay? So 10 kilo. Now, Spencer, if you want to size me a fuse, let me give you an option. The option for this fuse. Options. Option number 1, I have 5K. Option number 2, 10K. Option number 3, 22K. Option number 4, 35K. Which size interrupting rating for a circuit breaker would be the best fit for this scenario, and why? Can I use the 5? If I use the 5, what's gonna look at the overcome protection device here? The available short circuit 10K. I can't use a 5 on a 10. You blow it up. So 5 is too small. 10. Can I use 10? My available is 10.4. I can't even blow it up. Can I use 22?
Yes.
Yeah, great. That's a good option. How about 35?
You could, but it'd be a bad option.
You could, but it's expensive. You could use a 35. Why would I use 22 versus 35? The price could be 20% extra between a circuit breaker that's rated 35 and the same size amp circuit breaker that's rated for 22. So my best option in this case will be 22K. Any question, guys? Very simple. You want the interrupting rating of the circuit breaker to be slightly equal or slightly higher than the available short circuit. Equal or slightly higher than the available short circuit. Any question, guys, about that? I promise you we will do. So if this is transformer is feeding my panel here, the transformer is feeding my panel, guys, right here, this panel, the main for this panel have to be rated based on this calculation, what? 22K. 22K. So that's just, so this will be a 22K, both of them, 22K, and obviously they're going to be tied together. On the primary of this transformer. Any question, guys? This is the simplest way of calculating short circuit. Later on, I promise you, we will be talking a lot about calculating short circuit through softwares and so forth. Okay, the last thing, yes, Mr. Bab.
Are you going to give us options, even though the calculation says 10, but are you going to give us options so that we can use it?
Yes. Yeah, on a test, you mean? Yeah, it would be an option. Or I would ask you calculate the short circuit, and you calculate this. On the master exam, they usually give you the options, and you have to do the calculation and pick the one that's not too large, fits. Okay, moving on, guys, to the last segment of my presentation, and then I will let you overcurrent protection coordination. Overcurrent protection coordination is a fancy name. I'm going to go back all the way to these slides. Okay, here you go. I'm going to go. If you guys go to this, these slides that you have. This one is 20 amp circuit breaker, 20 amp, 2.8. Okay, I want you guys to look at this system. I have a transformer exactly like the one that we just did, and I did the short circuit. Available right at this point, and it came up with 20.8 K. This is a 20.8 K kiloamp, and we calculate them also downstream. So, and I'm tying a panel, a disconnect fuse panel to this system. Now, my question for you is, what do you guys think the fuse size have to be, based on the example that I did before? So it's 20.8. Can I put 10? No. So it's going to be 22. So this has to be 22 kiloamp. What do you think the lower ones has to be?
Less than 22.
Less or 22? Well, the answer depends. The answer depends. Do you want the system to be fully rated? They call it fully rated. Fully rated means, hey, Chad, this is going to be 22K, all of them. Each one of them is going to be 22. Each one of them, the downstream, the feeders, the branch circuits, each one will be 22K. This system is called, is it written here, guys? It's called fully rated. Why? What's the term fully rated? Means the branch circuits and the feeders and the main are rated for the same amount of short circuit. The feeder short circuit rating and the main have the same value for short circuit, right? Which is larger than the available short circuit. So any one of these boys can handle the battle, right? That's fully rated. Everybody's okay. What's wrong with this, Brad? Expensive. If you get it, now we're not talking about this, we're talking about 400 amp panel, 600 amp panel, 800 amp panel. You have an 800 amp panel, fully rated, 65K each one of them. Very expensive, very expensive. So the drawback, and we will come and visit this one, the drawback of this one is expensive. Okay, expensive for your application. And I will tell you guys, don't ask me now. Later on, we'll tell you where this is the best application for motors and so forth. This is the best application, basically, if you have motors. If you have a lighting circuit, a panel for light and receptacle, will be the worst application that you can have. Questions about fully rated? Questions about fully rated? Very easy. Look at the short circuit, and then rate the overcome protection device to equal or more than the short circuit. Okay, moving to the second one, guys. The second one is series rated, what they call them series rated. So look at this. Now the same situation, the same panel, the same situation, guys. I have the same situation. I have what's going on? What did we do with my stuff here? Okay, now I have a 20.8 kilo amp right here available right at this point. Available. If I short the 3 phases together, or 2 phases, if it's 2 phases, that's what I want to get. Now look at that big boy. That big boy, I rated this big boy for 22 kilo amp. Brooks, is that good? I rated my main to handle the available short circuit, the big boy, the main. Okay? Now the downstream ones, guys, I can, if they're series rated means the manufacturer will rate the main to work with the feeders downstream to work together to interrupt the short circuit. This is how it goes. Then all these I can go and rate them for 10 kilo amp. Look at that. The available short circuit, Chad, is 20.8, and your feeder short circuit is 10 kilo amp. They're going to blow up, right? No. Why? Because there's a big boy, that main circuit breaker right ahead of it, that will protect these little ones from a high short circuit. The way they work, guys, by manufacturer, these 2 circuit breakers, the main, the fuse, and the circuit breaker work together. These work together. If I have a short circuit right in here, look at that. If I have a short circuit right here, and the short circuit here is 15 kilo amp. Look at the scenario right in here, a 15,000 amp short circuit. This circuit breaker, which is rated for 10, will see that there's 15 going through it and will do nothing, would not try even to interrupt it by design. And it waits until the main interrupt it. So by the manufacturer coordinate their curves, the way they work, guys, as if the short circuit downstream is higher than the feeder's overcome protection device rating, then they will not interrupt it. They'll just stop and wait for what? Wait for the main to interrupt it. Now, what's that disadvantage, Brad? You're going to tell me, oh, Chad, every time I have a short circuit in any one of these high short circuit, what's going to happen to this? Trip. You lost the whole panel. That's a disadvantage. If you have a short circuit anywhere on these, you lost the panel. Now, this is if the short circuit, why would you do something like this? Now, look at that, guys. If the short circuit right here, if I have my short circuit is 10 kilo amp or lower, look at this scenario. I have a short circuit right at the feeder, 10 kilo amp or lower. Which one do you think is going to take care of it? The little guy is going to take care of it. And Brad, most of your short circuits are ground faults, and most of the ground faults are small amps. That's why it's not a big deal. Most of your short circuits are really much, much lower than this downstream. Most of them are much, much lower than 20.8. That's why this is a good application. So you're going to find most of them on the feeders are ground faults, and the ground faults are low, and most of them will be 10 or below. Most of them, not all of them, most of them. So this circuit breaker will protect me from, if I want to give a percentage-wise, guys, this circuit breaker will protect me up to 90%. 90% of the time, the circuit breaker, this guy will trip. And only 10%, the main has to trip. Be it. Kind of be it. If only I can handle this 10% of the time. I can handle losing all the panel for only 10% of the time. What's the alternative? Is to size everything fully loaded. What's the advantage of this? Now this is cheap product. Now you can have cheaper product, more affordable, cheaper product, smaller. Another advantage, smaller size, cheaper product, smaller size. That's the main advantage of series rated. Why do they call them series rated, guys? Because look at that, in series, one at a time. They work together. If the short circuit downstream is higher than the little guy, it stops, the main will take care of it. If the short circuit downstream is equal or less to that little guy will handle it, which is 90% of the time. Be it if I can trip the main 10% of the time. Versus I have a cheaper product.
So,
I want you guys, 1 second, I want you to write next to this. This is very common for lighting panels. You have a panel for lighting, 2 receptacle panels. And now we're talking about commercial. We're getting to commercial. In lighting panels like this panel, what do you think out of this panel? Do you see any air handling units fit here from this panel? Nothing. All what you see out of this little panel is what? You see a lot of lights and receptacles. That would be a great application for a series rated panel. Cheaper product, smaller product, more affordable. Any questions about series rated? Everybody knows what series versus fully rated. You're going to hear me talking, and also a guest speaker next time, Cutler Hammer, will come, guys, and talk about the same thing. So if you get it now you can go home on call ID. Oops, did I say that? We'll take you on a chat. Any question, guys, about big name series rated and fully rated for nothing? Now, knowing that DJ will do that, no problem. If that was a QP circuit breaker, DJ, a QP, you cannot go change it with a QO, 20 amp QP. QP is a type of circuit breaker. Are they Siemens? I think Siemens. QP. QO is a square D. If this is a QO circuit breaker, and in a panel series rated, you cannot change it with a QP or a home line. You have to change it. That's a drawback. You have to, if it's a series rated, you have to change. If you change any or add any, you have to add the same type of circuit breaker. Big deal, Chad. I add it anyway. So that's kind of it's not really a big issue. It's just when you change any of these circuit breakers or fuses, you have to use the same fuse type, not just amp-wise. There's 20 amp. There's many manufacturers 20 amp. From home line to QP to QO to a couple of others. You have to use the same type when you change it. Any question, my friends? Any question? So that's basically the fully rated versus series rated. The other ones, guys, you can have fully rated fuse with a fuse, fully rated fuse with circuit breakers. Look at that. I have a fuse with circuit breakers. You can have a circuit breaker with circuit breakers. So you can fully rated or series rated. So either fuse with fuses, circuit breaker with circuit breakers, or circuit breaker with fuses, and you can mix and match it. You can mix and match it. The only thing, if it's series rated, guys, the manufacturer have to label it as series rated, not me. Well, if you read it, do the code, engineers can do in the field series rated, but you have to have a study and document it and all the stuff to say I'm going to use a different type of circuit breaker here, and I'm willing to stick my head and get sued if something happens. Any question, guys? Overcome detection coordination, guys, and the last thing, which you guys are going to be doing a lot, overcome detection coordination. If you have a short circuit, as we know, let me just go back to which one was the series fully rated. Just talk a little bit about, this is a fully rated, right? They said fully rated. Being a fully rated for overcome detection coordination, guys, NCDM, if I have a short circuit right here, which fuse do you want to trip? Not here, not that guy. So you want this fuse to trip before that fuse. That's overcome detection coordination. The circuit breaker closer to the action, to the short circuit, to the ground fault, will trip first. The fuse closer to the action will trip first. Now, Holly, knowing that if your system is series rated, overcurrent protection coordination is not the best. It's good up to 90%. Remember how we said it's good up to 90 series rated, 90% of the time. If you have a short circuit in a series rated, In a fully weighted, 100% of the time. Fully weighted guys, 100% of the time. If you have a short circuit right here, guaranteed that this guy will open before that guy. A fully weighted. Series rated, you're good up to 90% of the time. So it's a risk that we can live with it. Not a big deal. So if it's series rated, I'm coordinated up to 90% of the time. Good, big deal. I can handle these 10% of the time. Which is these 10% of the time, DJ, is somebody like yourself grab it's a 3-phase break, hot A, hot B, and hot C, and tie them together under one wire knot. I mean, who stupid will do something like that? It could do. You're pointing to me, look at that. Now you lost 5 points. You know, you go tie
You
him.
started the house on fire.
Not me, my journeyman. I'm the master, man. Any question, guys, about the overtime fishing coordination? Any question about the overtime fishing coordination? And that will wrap our presentation for the quarter, gentlemen and ladies. And we will recoup. We will restart in 2 weeks or so. Presentation wise. New material. Thank you. 5 minutes break, and we're going to review the test. Are you upset or what did you?
No, I'm so
All the
excited.
stuff I
Really
got right.
excited
All
to
of
get
it.
I got a couple issues on this.
Couple of issues. Ah, you guys can't handle stress.
Can't handle structure.
You gotta hit it.